Good morning, all. So, in today's class, we are discussing about module 3, that is data structure. Inside the data structures, that is linked list. So, in linked list, we have studied singly linked list. Next, we go with a circular linked list. Next, double circular linked list and doubly linked list. Okay, so in today's class, we are going with a new topic, very important topics. Okay, so this is considered very important concepts from exam point of view. So that is, what are all the applications of the linked list? So where all the applications of the linked list? So very important concept. Kindly go through these two concepts. Okay. So applications of linked list. So in that first one, we are going with a stack, implementation of stack. So how you represent stack? So stack using linked list and queues using linked list. Okay. So stack consists of one pointer, so that is only one pointer, and that one we call it as top. Okay, so stack will consist of only one pointer. This is not I, this is one pointer, that is top. That means if you are going to insert an element, so you have to place that element at the top only. If you are going to delete an element, then topmost element is only to be deleted. Okay, so stack will have one pointer, that is considered as top. So come for the second one, queue. Queue will have how many pointers? So Q will have two pointers. One is the rear pointer, the other one is front pointer. So these are the two pointers what you are going to take. So keep this one in your mind. So, but in our linked list, you are having, in our linked list, you have how many pointers? So you can take an example. So in our linked list, you will be having, depends on type. If it is singly linked list, you are having only one pointer, and that one is called as a next pointer. If you go with a doubly linked list, you will be having two pointers. One is the previous pointer, the other one is the next pointer. So keep this one in your mind. So linked list, you are going with a implementation. Implement stack using linked list and queue using linked list. So for that, you have to remember how many pointers the stack and queue will have. So stack will have only one pointer, and that is called as a top. The queue will have two pointers. The one is called as a rear, the other one is called as a front. Okay, so now you come for the linked list. So in linked list, you will be having different types. So under that different types, first you go with the concept of singly linked list. So singly linked list, how many pointers will be there? So it consists of only one pointer, that is called as a next pointer. So when you go with a doubly linked list, you will be having two pointers. So one is the previous, the other one is the previous, the other one is next. Okay, so now you come for the concept stack using linked list. So implementation of stack using linked list. So how you going to insert insert a node and how you are going to delete a node. So keep in your mind in stack using linked list. So you are going to take singly linked list. Okay, so singly linked list will consist of how many pointers? It consists of, each node will consist of how many fields? Two fields. One is the value field, the other one is the pointer field. Okay, one is the value field, the other one is pointer field. So that is pointer field means it is a next pointer which contains what the next pointer will point to. It points to the next node. So it contains the value address of the next node. So as you all know, the pointer, what is a pointer? Pointer will contain the address of another variable. So here next is a pointer which contains the address of next node. So this one is node 1, this one is node 2, this one is node 3. So under that, now you see if this is for insertion and this diagram is for deletion. So you can see here, so new node is there. New node means you are placing a new node at the beginning. Okay, so keep this one in your mind. If you are going for an insertion implementation of singly linked list, so insertion at beginning and deletion at beginning is easily implemented. So keep in your mind, because the stack, so in the stack you can insert the topmost element and you at the topmost element, and you can delete the element at topmost only element only. So keep in your mind, so where you can insert onto the top and delete onto the top. Okay, so that is the, now you come for the explanation. A stack can be easily implemented through a linked list. So which linked list you are going to take? So here we are going to consider single linked list. Okay, so stack, as I already told, the stack will contain how many pointers? So anybody can answer? The stack contains how many pointers? One pointer. Okay, which one it is? Top. Okay, so how, where can you insert and delete in the stack? So can you insert and delete at different locations in the stack? Okay, you can insert at the beginning. So it is not beginning, you can insert a new element at the topmost. Okay, so that we are going to see it in this particular example. So now you come for the insertion. So this is the top. Okay, so this is the top element. So usually the top is pointing to the topmost element. This is node 1, this is node 2, this is node 3, which are already there. Okay, so for that you are going to insert the new node at the topmost element. Keep in your mind, you can insert and delete an element at insert and delete a element at only one end, that is called as a top end. Okay, so now which is the topmost element? So this one is the topmost element, because it is when you go for the stack, so this is the first element, it will go down. This is the second element, it will go down. This is the third element you are having. So top is will be pointed by the third element. Okay, so for that now you are going to insert a new node. So for that now you are going to insert a new node. So if you are going to insert a new node, what should be done? So now top, which is pointing to node 1, it should point to new node. So keep this one in your mind. So top, before insertion, the top is pointing to node 3. So this one is node 4. Okay, so now the top which is pointing to node 3 should now point to node 4. Okay, once it points to node 4, so node 4 next pointer should point to node 3. Keep this one in your mind. So I'm going from node 1, node 2, node 3. Understanding? So if this is the case, so now top which was pointing to node 3, so you can take it as node 1 also. Okay, but if I consider this one as node 1, this one will be node 2, this one will be node 3, and what you insert, this one is called as a node 4. Okay, so top which is initially pointed with node 3 will now should point to node 4, because you are inserting a new node. If you insert a new node, the next pointer of node 4, that is new node, should point to where? It should point to node 3. Okay, so that is the concept. Okay, so now you come for this one. So stack contains a top pointer. So top pointer, which is the head of the stack, where pushing and popping items happen at the head. If you are going to insert, if you are going to remove, everything should be done at which end? It is top end only, because the stack has only one end open. So it contains only one end open. So that one we consider it as top. Okay. So in linked list implementation, nodes are maintained non-contiguously. Each node contains a pointer to immediate successor. Each node is containing what? Each node contains data field and pointer field. So each node will contains a pointer to immediate successor. So this one is node 4, its successor is node 3, its successor is node 2, its successor is node 1. Okay. So that is the insertion. Now you come for the deletion. So now you see if this is the initially. So initially the topmost you are deleting, this is the deletion because you are performing a free or remove. So under deletion, first you see, so top is pointing for top, this is node 1, node 2, node 3. So if you are deleting this node, what should be done? If you are deleting this node, you have to cut the links between these two. If you are deleting, first you should remove, there is a link from top to node 1 and there is a link from this node to this node. So that is been removed and you have to make a node, a link to top to node 2. So top to node 1 link should be removed. Node 1 dot next which is pointing to node 2 should also be removed. If you remove these two links, this node can be easily deleted. Understood? So if you remove these two links, this link will be easily removed. Understood? So now you come for the program. So this is the program for stack using linked list program. So if they ask you, so I am marking you star. So star means it is very, very important. Okay. So it is very, very important from exam point of view. You have to go through. Understood? So first stack using linked list. So first you define a node. Each node will consist of how many fields? Each node will consist of one singly linked list we are considering. So each node will consist of two fields. One is the data field, the other one is next pointer field. So next is the pointer field. So initially top is equal to null. Okay. So now you have to go with a push operation. The other one is pop operation and the third one is display operation. First you come for the push. Okay, if you are going for the push operation, first you means you are inserting a new node at the topmost element. If you are inserting a new node, take that new node as temp. So temp we consider it as, so temp is considered as new node. Okay, so allocate. So this is dynamic allocation. Dynamic allocation using malloc. Okay, once you allocate, so now you have two fields. So that is new node is considered as temp. Temp then data you give value and temp then next you show it to the top because you are inserting a new node. Okay, so initially what will be there? Temp, this is the temp. Temp then data is equal to value. Temp then next should point to where? Node 2. So node 2 will be pointed by whom? Top. So that's why we are here. We are making it as temp then next is equal to top. That means where the top is pointing. Initially top is pointing to node 2. So here the next pointer is pointing to the node to which the top is pointing. So ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. So temp node dot next it is pointing to node 2 and that has been pointed by temp. Okay, so that is been pointed by temp. So that's why we here you give it as temp then next is equal to top. So very, very important line. So after that now you have to make temp is equal to top. That means temp is equal to top. So that marks this line. So this is the temporary, this one is top. Temp is equal to top will mark this line. Understood? So now you come for the pop operation. So initially pop means you will be removing the topmost element. So if you remove the topmost element, what should be done? So take a node and a variable n. Okay, so initially you make it temp is equal to top. So you make it temp is equal to top. That means initially what will be the case? Topmost element will be removed. So which is the node you are going to remove? You make it temp. Okay. So what the n contains temp then data. So next to point top is equal to top then next. So top is equal to top then next means, so where is top pointing? This is the top. Top is actually it is pointing to temp. So this is the temporary what you are going to delete. So temp, so come for this case, you make top then next. So what is top? Top is nothing but temp. Top is nothing but temp. Okay. So temp then next is moving to where? Temp then this is the temp. Temp then next is moving to some node. So temp then next you make it to top. So what is temp then next? It is node 2. So node 2 should be pointed by top. So that's why we give it as temp then next is equal to top. That means you are deleting this particular node. You are removing this arrow mark. So node 1 dot next is pointing to node 2. So once you want to delete this particular thing, what you will do? So you will remove this particular link. So temp then next, what is the temp then next is pointing to node 2, and that node 2 will be pointed by temp. So that's why we give it as temp is top is equal to top then next. Okay, so once you assign top is equal to top then next, now we are going to free the temp. Okay, so what is the temp data you are having here? So temp is nothing but top, you are assigning top is equal to temp, and the moving the value temp then data, n is equal to temp then data. What is the n value now? If you are removing this one is temp node. Okay, so if you are removing this particular node, you have to remove this one. So this one is temp. So top then next. So top then this is considered as top. Top then next should point to top. So that's why we are giving it as top is equal to top. Then next, once you assign, you can go with free of temp. So what the free will do? Free will remove the node. So which node you are going to remove? You are going to remove the temporary node. Okay. So now you come for the display operation. So that is push, this one is pop. So come for the display operation. So display all the elements starting from top. So keep in your mind, display all the elements starting from top. So if top double equals null, printf it is null, else you are printing all the data. So how you print the data? So here you see we are printing the value along with their address. Okay, because each node will consist of value with next pointer. Next pointer will contain what? Address of the next node. So that's why we are going to print the content. %d for value, %u for address. So %d for value means top then data. So %u address means top then next. So display of top then next. Okay. So now you come for the main function. So under the main function, first you are pushing 10, next you push 20, next you push 30, next you push 40. So which is the topmost element? Here you see 40 with its address, 30 with its address, so 20 with its address, and 10 with its address. So last one will be implemented as null. Okay. So now you are displaying all the elements. So displays this. Now you pop the element. So popped item is equal to pop. So which is the popped item? So you are popping that 40 element. So 40 will be removed here. So here you can see the popped item is 40. So after that, now you are going to display. Once you display, the 40 will be removed and remaining things will be there as it is. So that we are displaying it here. Understood? So you have to go with this particular program. It's very, very important. So understood The concept. Any doubts in this? No doubts? Sorry. I will, if you didn't understand, I will tell you what are all the steps. Okay. So initially, this one is node 1, node 2, node 3. So top will be pointed by node 1. So node 1 will consist of two values, two fields. One is the value field, the other one is next field. So value field contains a data, next field will contains address. It contains the address of the next node. Okay, so if you are inserting a new node, so what should be done? The top, which is pointing to the node 1, should point to the new node. Okay, and next pointer of the new node should point to the node 1. Okay, so if I take this one as node 1, node 2, node 3, the pointer which is pointing at node 1 should point to node, new node. Okay, so I can take it as node n. N means new. Okay, node n, and next pointer of the node n should point to node 1. So this is the insertion operation. Come for the deletion operation. So deletion, initially if you are deleting the topmost element, so top will be pointing to node 1, and node 1 dot next will point to node 2. So if you want to delete this node, so you have to cut the link of node 1 and cut the link of next pointer. Okay, so that means what now initially top is pointing to node 1, and the node 1 dot next is pointing to node 2. If you delete these two links, then you have to make a new link. So new link has been made from top to node 2 because node 1 is been deleted. So that's why we take it here. So come for the code of insert. So first you create a node. Now you give the new node is considered as temp. Okay, this one is temp node. So temp then data is equal to value. Temp then next. What the temp then next should point to? So that we give it here. Temp then next is equal to, it should be pointed by top. Okay, temp then next point ಮಾಡ್ತಿರೋದು ಯಾವುದು? Temp then next should point to node 1. So this node 1 is already pointed by whom? So it is already pointed by top. So that's why we give it as, temp then next is equal to top. So where the top is pointing? Top is pointing to node 2. Our temp then next will should point to node 2. Next you make this temp as top. Okay, then you make temp as top. Now you come for the deletion. So under deletion, what are all the things you do? First you take a node. So assign temp is equal to top. So this is the very important line. The node that we delete, we call it as temp. Okay, so that is TMP, and value there in that node is considered as N. So value present in that node. So value what is present in this node will be considered as N. So next you make temp is equal to top. So now you are making temp is equal to top because temp is being pointed by whom? It is pointed by the top. So this line you are telling you this is the temp. Temp is equal to top. That means you are assigning top to temp. So top is being assigned to temp. Next line you take n is equal to temp then data. So now you mark top is equal to top then next. So what is top then next here? So top then next, this one we marking it as top then next. So top then next is pointing to node 2, that one you make a assign to top. So that's why top then next which is pointing to node 2 should be pointed by top. So that's why we give it as temp then next. Temp then next is pointing to node 2, that one we are making it as top. Okay, so once you make top is equal to top then next, that means here we are going to assign temp then next. What is temp then next? Temp then next is equal to node 2. The node 2 is being made as top element. So assign node 2 is equal to top. That's why we give it here. Node 2 is going to assign it as top. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, this is temp then next which is pointing to node 2 should be made as top. That's why we give it here assign node 2 is equal to top, then you free the temp. Okay, now you people got. So after that, now you are displaying all the elements from the topmost element. If top equals null, no stack. Else, if top is not equal to null, you are printing the values. One is the data, the other one is address. So data will be pointed by top then data and address will be pointed by top then next. Okay. So this is the iteration of stack using linked list. So remaining the next one, queue using linked list, that we shall see in the tomorrow's class. Okay, I hope you all got understood this particular program. So go through all the videos and understand the concepts, because these concepts are very, very important up to 7th and 8th sem also, because everywhere you are going with stack, queues, linked list, everything. Understood? So go through this particular VLHS and subscribe for my channel to get the next coming videos and all. Okay, I will be ending this particular session. Thank you one and all.